This is problem 5, and this problem is a little bit different. So now we have a capacitor C1 that was connected to a battery of voltage V1, and it was fully charged. After that, it was put in another circuit. It was connected this way, plus and minus, to another capacitor C2 that was initially uncharged. It was connected to the battery with voltage V2 and resistor R. What we need to find, we will split this problem into two. Part A. For part A, we need to find when all charges come to rest, what will be the charge inside this box indicated by this dashed line? What will be the charge after all charges come to rest? Okay, so first of all, we need to find what was the charge on the plates of C1 when it was connected to the battery V1. What is the charge? We will call it Q1, and it is equal to C1 V1. Now, when I bring this capacitor to this circuit, we need to indicate the charges. Well, after charge redistribution, we will have plus on this side, let's call it Q1 tilde. It will be new charge after charge redistribution. And this plate will have minus Q1 tilde. And for this capacitor, let's call this charge on the right plate Q2 tilde. And this one will be minus Q2 tilde. What will be the charge within this box? We will use conservation of charge that tells us that charge within this closed space, within this box, stays the same. What was original charge when we just put this capacitor C1 in this circuit? Capacitor C2 was uncharged, so initial charge on the plates of C2 on this plate was 0. The initial charge on this plate of the capacitor C1 was Q1. This was the total charge within this box when we just put this C1. And now it has to be equal to the same charge within this box after the charges have been redistributed and come to rest. So what is the total charge now? It is minus Q2 tilde plus Q1 tilde. This is the total charge within this box after redistribution. And this total charge is equal to Q1. And Q1, we know Q1. It is C1 and V1. Both these numbers are given, so we found the total charge within this dashed box after charge redistribution. For part B, we will find when all charges come to rest, what will be the charge on the left plate of the capacitor C2. So what we need to find, Q2 tilde. We decided that it is positive, so now let's try to find Q2. Which equations we will use? As always, we will use our equation integral E dot dr around closed loop is 0. And also we will use conservation of charge that we used in part A. Let's go around this loop. Which way would you like to go around the loop? I will choose clockwise. If I go around clockwise direction, from minus to plus, I have positive change in voltage, negative change in E dot dr. I put minus V2. Then we come, by the way, I didn't follow the steps. I have to mention this, that we start with the direction of current. So what is the direction of current? Well, I choose current, let's say, in this direction, but immediately understand that I have capacitors in this loop, and in steady state situation, the current through capacitors is 0. So no current through the capacitors, which means that voltage change across this resistor is 0 because voltage change or E dot dr change across this resistor is just current times R. So this resistor will not be part of this equation because this guy will be 0. We keep going. It is minus V2. Now we come to this capacitor C2. We go in clockwise direction this way. Okay, this is our dr. And then electric field with our choices is to the right. So this E dot dr guy is positive, E to the right, dr to the right. Magnitude is Q2 tilde over C2. And then we keep going from plus to minus. Electric field is to the right. dr, we go in this direction. dr is to the right. E dot dr is positive, I put plus. Then I have Q1 tilde over C1. And since voltage change across resistor is 0, current is 0, we close the loop. This is 0. I have one equation and two unknowns, Q1 tilde and Q2 tilde. So I need one more equation. I will use this equation. Conservation of charge. Minus Q2 tilde plus Q1 is equal to C1 V1. And now I have a system of two equations and two unknown variables, Q1 tilde and Q2 tilde. So we need to get rid of one of these charges and solve for another. Which one we will express in terms of another. Now I will express Q1 from the first equation, from the second equation, I'm sorry. Q1 is Q1 tilde is Q2 tilde plus C1 V1. And then I will bring it to my first equation, which will give me minus V2 plus Q2 tilde over C2 plus Q1, which is Q2 tilde plus C1 V1 divided by C1. And this is equal to 0. Now we solve for Q2, which is easy. We will factor out Q2 tilde, and then if I factor out Q2 tilde, I will have 1 over C2. Oops, 1 over C2, sorry. Q2 tilde, and then in parentheses, I will have 1 over C2 plus 1 over C1. And then it will be equal to V2 comes to another side of the equation, V2, and what is left is I will bring this guy to the right with minus. C1 over C1 is 1, so it is V2 minus V1. Wonderful. So what is Q2 tilde now? It is equal to V2 minus V1. And then I divide by this guy, 1 over C2 plus 1 over C1. This is Q2. And Q1, this is the answer for Q2. And Q1 is Q2 plus C1 V1. We solve the problem.